Okay, guys, Timmy coming at you again. And today, what I'm going to do is I'm going to explain to you some of the homeostatic mechanisms the body uses to stay in balance. Um, just a real quick recap. Remember that the fundamental principles of the body are number one, and the most important is the goal of the body is to maintain homeostasis. So, if you look, again, the most important part of your body to maintain that internal balance in is the core. And the core of your body includes your vital organs and your brain. And one of the things that the body has to maintain for you to work really good is your blood sugar. Blood sugar, blood glucose, same thing. So the homeostatic levels for your blood sugar, where your body works best, is between about 80 and 100 milligrams per deciliter. So that means that floating around your blood, there's about 80 to 100 milligrams of glucose in 100 cc's of blood. And the reason it's really important is, and I would write this down, tattoo it someplace, is the only fuel your brain can use, at least right now, is glucose. So for your brain and your central nervous system, which really controls your body ultimately minute to minute, second to second, if your blood sugar is high or low, your nervous system's not going to work so good. So that means you ain't going to work so good. So what I'm going to do is I'm going to explain to you how we maintain our blood sugar. So a couple of things. Number one, the hormone that is involved in maintaining your blood sugar, which I'm sure you're all familiar with, is the hormone insulin. And again, insulin is a functional protein. So in this case, insulin is going to tell the cells of your body to do something. And because insulin is involved in controlling your blood sugar, it's going to tell the cell to do something with the glucose. So insulin is really the key when you talk about metabolism and when you talk about blood sugar homeostasis. So a couple of things that you really got to understand, and that it's intuitive, but I want to make sure that you get it. Okay. A, if you eat sugar, right, you have some Kellogg's Sugar Smacks, dig them. If you eat sugar, in about 15 minutes or so, 15, 20 minutes, depends, that sugar that you just ate is going to go into your bloodstream, right? You get it digested, you eat Kellogg's Sugar Smacks, dig them. And that sugar that's in that cereal gets broken down and then it gets absorbed into the blood. So anytime you eat sugar, it's going to cause an increase in your blood sugar. So I'm kind of making this up, not really, but just give you an idea. All right, let's say that you're studying and your blood sugar was 80. And you say, hey, I'm hungry. So you eat something, right? And in about 15 minutes, that's going to cause your blood sugar to go up. And let's say your blood sugar goes up to 140. Now, at what range does your brain central nervous system and ultimately your body work best? Well, the answer is between 80 and 100. So now your blood sugar is above that range, so you're not in homeostasis. So your body's got to do something to get you back. And what it does is this. I'll show you a little video. So here we go. Your body. This is actually my sister. I'd like to point out a couple of things, one in particular. You notice the muffin top. Yep, she needs to lose weight. And here's the thing, I've known this lady for over 50 years, and I never noticed the fact that I could see her esophagus, liver, and stomach. Anyways, I digress. So here we go. There she is. And there's the anatomical location of the pancreas. And again, the pancreas is involved in controlling and maintaining blood sugar. Blood sugar, blood glucose, the same thing. And again, what's important is the fact that the brain relies on glucose from the blood. All right, I'd like to point out here, what she's doing now is she appears to be eating what looks like a moldy chocolate turtle. Not sure where she got it, but anyways. So watch. What's that chocolate turtle made out of? It's made out of fat, carbs, sugar, and protein. So when you eat, it gets into your stomach and you begin to break down that chocolate turtle into its parts, which are fats, carbs, and protein. So now you've elevated your blood sugar. So when your blood sugar is elevated, let's say it goes to 140, your pancreas is going to sense that. And when the pancreas senses that, it releases into the blood the protein insulin, the hormone insulin. And hormones, by definition, or at least my definition, they tell the cells of your body to do stuff. So this is the critical piece right here. And if you're going to understand diabetes, you got to understand this, that glucose, this guy right here, what up, G, is impermeable to the cell membranes. Glucose cannot simply diffuse from the blood into the cell. So embedded on all of your cells are little receptors. And these little receptors, which are obviously, or not obviously, but coolly, I guess, these little receptors are made of protein. And you're not going to believe this. This will be a shocker. But this little protein receptor on all cells is called, hold on, an insulin receptor. Now this is key. This is key. All right. Again, glucose is impermeable to cell membranes, but you have to lower the blood sugar, and how you lower it is by getting the glucose out of the blood into the cell. So this is where insulin comes in. So embedded in your cell membranes, all cells, you have these insulin receptors. And when insulin that's now in the blood, because it was released by the pancreas, binds to an insulin receptor on the cell, what it will do is it will open up a protein gate embedded in your cell. So it will open up this gate, And if you want to know the name, it's called the GLUT4 transport protein. And when that gate is opened, it will allow the glucose that was in the blood to now diffuse from high concentration in the blood to low concentration in the cell. And that will lower your blood sugar. The question is how long does the pancreas secrete insulin? And the answer is until your blood sugar is back between 80 and 100, back to homeostasis. So because you're trying to get back to homeostasis, if you read in your book, the control of blood sugar is what's referred to as a negative feedback mechanism. So what caused the insulin to be released was an elevated blood sugar. What stopped the release of insulin? When you got your blood sugar back to that homeostatic level. And this is how the body works, because our goal is to maintain homeostasis. The vast majority of mechanisms like insulin and glucose are negative. They want to get you back to homeostasis. Now, from a clinical perspective, this is absolutely critical. I'm going to pause a little moment of silence so that you get this. So watch. In order for your blood sugar, you had glucose in the blood because you ate some sugar. In order for glucose to go from the blood into the cell, two things have to happen. Number one, the pancreas has to release insulin. Now, if you have a condition where you eat sugar and your pancreas does not release insulin, you cannot lower your blood sugar. So if you don't have any insulin, you have to take insulin, and you have to take insulin for the rest of your life. So a person who cannot control their blood sugar because their pancreas does not release insulin is a type 1 diabetic. This usually happens earlier in life. It was referred to as juvenile diabetes, also because the kids who developed it, they had a tendency to steal hubcaps or radios, and they were termed a juvenile. I'm just kidding. Anyways, so that's a type 1 diabetic. And the reason they have to take insulin is because their pancreas doesn't produce it. Now, here's a question for you. If the insulin has to get into the blood in order to lower your blood sugar, and if it's a person is a type 1 diabetic, why don't they just shoot the insulin into their blood? Why don't they directly put the insulin into the blood? Why do they inject it into fat? Well, the answer is this. Look at this little graph here. Watch. Here your blood sugar was 80. Right? Here's a blood sugar of 140. And then here is time. So right here, your blood sugar was 80, and you ate some Kellogg's Sugar Smacks. Dig them. Your blood sugar does not immediately shoot up. right? It doesn't go up quickly. What will happen is it will go up over time, usually 15 to 20 minutes. So your blood sugar is going to be at 140 in about 20 minutes. But if your blood sugar was 80 and you inject that insulin directly into the blood, it will lower your blood sugar, and it will lower it very quickly. So that's why when a person is given insulin, they give it into the kind of the fat portion, the subcutaneous tissue, because that means that the insulin will get absorbed into the blood at the same rate that your blood sugar goes up. And that's how it helps control your blood sugar. That's in a type 1 diabetic. Now, again, in order to get your blood sugar down, number one, you got to have insulin released from the pancreas. The second thing that has to happen is that insulin has to bind to a functioning insulin receptor on your cell membrane. So if either one of those conditions are not met, your blood sugar is going to be high and you will be a diabetic. So let's say, for example, grandma, she wasn't diabetic as a young lady, but she started getting a little tubbier, a little more sedentary. And what happens in people as they get older, this is important, the number of insulin receptors on the cells goes away. Hang on.